You know, I really enjoyed that favourite chicken.
My favourite part was the chicken.
I'm with you on that.
Yeah, I really like it. Although I'm a little worried.
Yeah.
In the burger was lots and lots of mayo, and I've heard that's really fat.
Yeah, I think just as a whole, my favourite chicken is
Pretty
quite fatty.
fat.
And I think, yeah, that's what we're on to now.
Yes, it is.
So we could teach them about fats too.
Firstly, fats isn't always bad. That's why we needed a favourite chicken before this video.
Because if we didn't have a favourite chicken, we could die.
Yeah,
eventually.
It's good for insulation. You need that. You always need.
You always need that, and it's a very good storage molecule. You can use it later, but you already know that because if you don't use it, well,
it builds up.
Yeah.
So it can be stored, and if you use it, that's a really good storage solution. Way better than those things you see on telly with all the drawers. That's not a storage solution, because then where do you store the wardrobe, you know? Problems.
It is a big problem. It has far more energy than carbohydrates do comparatively as well. But Wayne, what actually is a fat?
Well, first we need to take a look at a little molecule I like.
Okay.
123 propane triol.
Oh, I've heard of that.
You should have done, because you've drawn it once already.
I have, up there. That's what it is. It's got another name. You normally don't call it 1,2,3 propane triol. You normally call it
glycerol.
There you are.
So these are hydrogens on this side, it's not important. Because this is an alcohol, you can make an ester which will make a triglyceride.
Yeah, and that is what all fats are. So you can just use any carboxylic acid, butanoic acid.
Butanoic acid will do. In actual fact, it's not going to be, well, it's not likely to be a short carbon chain. It's likely to be an insoluble one.
Yeah, 10 plus or 4 plus would be insoluble, but it's likely much larger anyway. So we know what happens. A OH comes from a carboxylic acid and an H from each one of these. It happens to all three. That's might be a misconception. It happens to one, it happens to all three.
You might think it would just happen to one. So what you've got to be careful of is putting a massive 3 in front of that, and a massive 3 in front of your H2O product.
Because it is a condensation reaction, so 3 waters are formed.
And you're going to form just the one of the ester.
Yeah.
And I'm not going to draw it because it's going to be big, but the O is going to then be bonded to that carbon.
Yes.
As if you don't know esters, you can check out our previous video.
Yeah, do that. The bond that forms between them, you have to know the name of it. This is all quite, well, I assume knowledge if you do biology. If you don't, never mind. It's called an ester bond, or ester linkage.
Yep, sometimes referred to as that. And that part would be where it's bonded, the whole thing. So to the carbon with this double bonded O. So if I just draw that section, that oxygen will be bonded to that carbon, which will still be bonded to that O.
Yeah,
and the rest of the chain
will happen. So
that bit is your ester bond there.
Yeah, so you might have to label that in an exam or something.
So now we've looked at that. Another way of drawing this is if we rub all this off. How they tend to like to draw is in skeletal because the chains are huge.
They are very large and also have sort of little differences. The main differences between fats is if they're saturated and unsaturated. You probably would have heard these words a lot in the media, but what do they actually mean?
Well, they're both carbon chains.
They are.
Long ones, normally, like this. So if I draw both, this one would be saturated, this one is now unsaturated, and the difference being this double bond.
So that's quite important. Not only does it change just the little structure, it can change quite a lot about what the fat does.
Yes, so first we need to look at what a double bond does itself before applying it to a large molecule.
So with double bonds you can have different types of isomerism, which includes EZ isomerism. So this is a bit of a revision from IS.
Yep, I'm going to do different colours here.
So Wayne's drawn a little isomer, what could be an isomer of EZ isomers at the top corner. We're going to do another one with different colour hydrogens. Normally it wouldn't be hydrogen because it wouldn't really be an isomer then, but yeah. So our two types from AS and now are cis and trans. This would be cis, this would be trans. The way to remember that is this is cis because they're sisters next to each other, and this one's trans so they transfer across the bond.
Yeah,
the two things.
Just like that.
Yeah.
That's how you do it.
But if you had a much longer chain, it makes a more obvious difference.
So if we start at the double bonded carbon, which would be in a long unsaturated chain, quick tip on how to remember which is saturated and unsaturated.
Yeah.
Saturated begins with an S, so single bond. Unsaturated always has a double.
Yeah.
So first let's look at the cis. It's when the rest of the chain is both up here on the same direction. It could both be down, same thing.
Yeah.
So then if we draw the rest of the molecule, it's going to look something like that. It's going to make this
sort of like a
V.
really weird, a really weird V. And we could also have trans, which would essentially form a straight chain.
Yeah.
So it would be the same as having a saturated fat.
And what that means is if this and the saturated, so the same thing but with a single bond in the middle,
Yeah.
they're both going to be able to stack. They're both going to form
Yeah.
bonds between the ones on top of them, and that's going to make it harder to break up.
And as it's harder to break up, it will have a higher boiling point, so it's more likely to be solid in your arteries.
Which causes a problem.
It does cause a problem. So we like cis unsaturated.
Much more than trans.
But it's not just because of the boiling points, they actually have different things in them as well.
They do indeed. So
Let's do this.
move on.
Again, biology buffs, this will be all easy peasy for you. It's to do with HDLs and LDLs.
And dropping
pens, which is very important.
So, HDLs is high density lipoproteins. It's where you've got a high density of lipoproteins. But what are lipoproteins is probably the more important question. Fats and cholesterol and stuff. So they can be carried around the body with these HDLs. Now HDLs are referred to as good, and the reason is they can carry the cholesterol to places where it's going to be broken down, so it's not going to be in your, or less likely to be in your arteries.
Yeah, it can remove free radicals and stuff, and generally it's the good one. And this is the one that's found in our unsaturated cis isomers.
So that's why they're good, is that they can be stacked, taken out of the body, taken to the liver or the pancreas.
Comparatively, we have LDLs, and these are low density lipoproteins that have a lower density of lipids, and these will be most commonly found in saturated fats or trans unsaturated fats.
Yeah, so the straight chains. And LDLs are bad because they deposit these things on your arteries.
Yeah.
Which means there's going to be a build-up and a blockage, so high blood pressure, increased risk of heart disease and stuff. And that's why we can't really get another favourite chicken.
It is. We probably will. But we shouldn't.
We shouldn't. We definitely shouldn't.
Definitely shouldn't, because it would be bad. But fats aren't all bad, are they?
They're not all bad at all, no.
So, in your body there can be storage molecule and things like that, but we can use them in other ways.
Yes, using them for energy in general. Energy for me to run to the shop to get another favourite chicken, or the energy in my car to drive to the shop and get another favourite chicken.
So, as you know, the quantity of crude oil is going down and it'll eventually run out, and we get diesel from this. But we can also make it using ethanol from plants, specifically rapeseed.
Yes, in the UK that's a very common one.
Yeah, you've seen it everywhere. The big yellow thing, that's what it's all used for.
Yep. So, we're going to make biodiesel on a whiteboard right now.
Yeah, it's going to be incredible.
So,
it's the future.
do you remember roughly what it looks like, Triv? I know it's got the 3 carbons just like this. To O. Is it to C, to double bonded O? I think it is, isn't it?
I think so. What I could do is we can check the book.
Oh, it is that because you've got... I remember.
You remember?
This.
You
yeah.
sure?
Yeah. It looks like this because here is your ester linkage and R represents the rest of the molecule.
Because this is a triglyceride, and R could be any length of carbon chain.
So the R could simply be a hydrogen, and it would literally, these are hydrogens as well, to make it 4 bonds per carbon. R could be a hydrogen, or R can be a whapping long carbon chain thing.
Whapping long is a technical term.
It is indeed. This isn't biodiesel.
No.
Because this has this ester linkage, if we reacted it with an alcohol with a particular catalyst,
Which would be sodium hydroxide.
would indeed, then we're going to get biodiesel with an alcohol.
Which is pretty handy. So we're going to do that.
Yeah. So, in actual fact, the alcohol could be any alcohol. Let's just do a simple one to make it simple.
That's a good idea. We could do ethanol.
Ethanol. Draw on that. Fantastic. So that's ethanol. So if you react this with an alcohol, it's going to create...
It'll be a reversible reaction.
So it will. Like that.
Yep, and a catalyst of sodium hydroxide. Now it will form biodiesel and an alcohol.
Yes, so if you didn't know what you were doing before with esters and you didn't check out our video, this is definitely a place to do it. When you're reacting things with an ester, with an alcohol, it's going to break up this ester linkage. So the result is going to be biodiesel, and you're going to get your eventual glycerol back. So C to C to C to OH on all of this. So this is the part that's going to break on all of them. So this is going to become a H. All of this is going to be separate, and that's going to be your biodiesel. So Triv's drawing up another whapping great thing. Whapping being the technical term.
Absolutely. So this is our glycerol.
Yep.
And then this is our biodiesel at the top.
And that's the biodiesel, as Triv said. So that's what you're going to get. Now, is biodiesel a friend or a foe?
Now this is a question I often get asked by a chemistry textbook. So it's said to be carbon neutral.
It is.
And carbon neutrals were essentially the plant takes in carbon, but when you burn it, it releases carbon, so you've essentially added no extra carbon dioxide to the atmosphere.
Plants take in a lot more carbon dioxide when they're growing than when they're fully grown. So if you let them all grow, they're going to take in loads. And when they're fully grown, use them for biodiesel. Yeah. Straight away would be the optimum. That's a bit of background information, really.
So that's a good thing. But poorer countries are growing a lot of this and selling it to richer countries instead of growing what would be normally land for food.
Yes.
And that's not a good thing.
It's not indeed. I've come up with this genius solution.
Yeah? Alright.
Right, you know, if you've got rapeseed, this is going to be a terrible drawing, but you've got the stalk, then you've got the bit that's edible at the top, then you can eat that bit at the top, you can cut that, and that can be done with stuff too.
Right.
My idea, this is all my idea,
alright, I'm ready,
is if we could cut off the top and still use that bit for food,
right,
we can still use the stem for biodiesel. Eh? Eh? So then we can do both in the same field. I'm going to invest in this. Are you going to invest in this?
First I'm going to see if it works.
Oh, it does.
Yeah, you sure?
Yeah, I've got a chalkboard over there full of maths. And also, I think because we've been talking about fats, we should get a salad.
I think that's probably safer.
But
salad
on a burger.
Oh, of course, yeah.
Yeah.